Okay, so this is page 22, lesson B9, estimating IROC and using limits to represent derivatives. Okay, so guys, we're going to start off on page 23. Okay, so pause the video and write this down. You don't need to use like the colors the way that I did, but so you'll want to pause the video to write this down. Estimating IROC. Other names for so IROC is instantaneous rate of change, also known as the derivative, also known as M-tan, which is the slope of the tangent line. So if you have a table of values, if you know that the function is differentiable, which means that it is both continuous and smooth, you'll learn in the future why smooth is important. But if they tell you that something is differentiable, it means that you can take the derivative. But so you got a table of values, you know the function is differentiable, and it depends on whether you're finding the derivative at an endpoint of the table, at an interior point shown in the table, or at an interior point not shown in the table. Okay, so like an example of endpoints would be -6 or 14 in this case. An example of an interior point shown in the table would be 6. So, or -2, 2, or 10. An interior point not shown in the table would be like 7 or 8 or something between the values that are shown. And if you know that the function is continuous, you know that the function has y values, at any of these interior points, even if they're not shown. Okay, so at an endpoint, you're going to estimate, you're just going to use AROC to estimate. If you're doing an interior point that is shown in the table, you will actually have 2 AROCs to choose from. If there's more than one AROC that you could use, then you want to average them. So this would be, so use average of left and right AROCs. Okay, so for this one, we'll have to find 2 AROCs and average them. At an interior point not shown in the table, you're going to use 1 AROC. All right, guys, so have that stuff written down, and then we're going to move to examples. So, alrighty, number 1, h of x is differentiable for all x. Okay, so differentiable. This means, this is not really a word, but I've heard some students say derivatable. It's not a real word, but it makes sense. So differentiable means derivatable. You can take the derivative. The derivative exists. And in order for a derivative to exist, the function has to be, so the graph is continuous and smooth. And you will learn, I think there's an E, no? I don't know. You're going to learn in the future why smooth is important. We'll learn that shortly. Okay, so estimate h prime of 6. Okay, so 6 is right here. So 6 would be an interior point shown in the table. So we're going to have to do the left and right AROCs. So this is for A. All right, so let's just show our work. So AROC on 2 to 6. Okay, so the AROC on 2 to 6 is 10 minus 6 over 6 minus 2. So 4 over 4 is 1. Okay, so the average rate of change from 2 to 6, that would be the left AROC, because you're to the left of 6, using a point to the left of it, is 1. Now we're going to do the right AROC. So AROC from 6 to 10, 5 minus 10 over 10 minus 6. -5 over 4. Okay, so those are the 2 AROCs, and now we have to average them. All right, so Now I'm going to use notation. So h prime of 6, okay, that's the IROC at 6, the derivative at 6. It's going to be 1, or I'll do negative 5/4. Negative 5/4 plus 1, which is 4/4, over 2. Okay, so I'm averaging the two AROCs. This is negative 1/4 over 2 over 1. Keep change flip times, okay, and this is an estimate, but our estimate is negative 1/8. Okay. Now for B, 14 is an endpoint. So it's not like we are showing points to the left and right of 14. So we only have one AROC to choose from. So this is part B, and we're going to do the AROC from 10 to 14. Negative 1 minus 5, negative 6 over 4, negative 3/2. Oh yeah, and by the way, guys, so I put an equal sign here, but if you do like two squigglies like that, that means approximation. So maybe I should do that instead. You'd never get taken off though if it's an equals. So h prime of 14 is approximately negative 3/2. All right, that's part B. Now part C, h prime of 0. So 0 is between negative 2 and 2. So 0 is an interior point, but it is not shown in the table. So really our only option, since they're not even showing the point, is to do the AROC on the interval where 0 falls, which would be negative 2 to 2. So AROC on negative 2 to 2, 6 minus 0, 2 minus negative 2 is 2 plus 2. Alrighty, so for part C, so h prime of 0 is approximately 3/2. All right, guys, there you have it. So that's how you estimate the derivative from a table. Now these examples down here, let's just do like 3 of them. So for 3 through 8, write the limit definitions for the derivatives, but do not evaluate. So we're not going to have to evaluate the limit, but we just want to write the formula. So let's do number 3. Let's do 3, 6, and 7 together. Okay. And guys, you should write this here for yourself. See page 3 for the formulas. Okay, so these formulas, we have to have them memorized. And if you're having trouble memorizing them, you really want to try to understand how the formulas come to be. Then it will be easier to remember. So this is what we're going to use if we're finding f prime of a specific number. This is what we're going to use if we're just finding f prime of x, which could represent any number. Okay, so the first one, or 3, that's number 3. Okay, so our function is sine of x. All right, so f prime of 3 is equal to the limit as x approaches 3. And now we do f of x minus f of 3 all over x minus 3. Okay, so this is f of x. So f of x is sine of x minus sine of 3 over x minus 3, and then you stop. Okay, now f prime of x is equal to the limit as h approaches 0. What goes here is f of x plus h minus f of x all over h. So for f of x plus h, guys, you just take the function, and where you used to have an x, you put the binomial x plus h. No, we're doing 6. I'm sorry. Oh, no, we're still on this one. I'm thinking too far ahead of myself. All right, so this is going to be sine of x plus h minus sine of x over h. Those are the answers for number 3. Okay. Now number 6. So for f prime of negative 2 equals the limit as x approaches negative 2, and it's going to be f of x, which is e to the x, minus f of negative 2 all over x minus negative 2, which is x plus 2. Okay, and then f prime of x is the limit as h approaches 0. F of x plus h, I'm just putting an x plus h where the x used to be, minus f of x all over h. All right, that's number 6. Now we'll do number 7. Okay, so number 7. Okay, f prime of 1 is the limit as x approaches 1. F of x is 2 over 3 minus x minus f of 1, you're plugging 1 in for x. So you're getting 2 over 2, which is 1. And then that's all over x minus 1. Okay, and now f prime of x is the limit as h approaches 0. F of x plus h, so I'm replacing the x with a binomial. So where there was just an x, there's going to be a binomial. So 2 over 3 minus x plus h, I need parentheses there, minus 2 over 3 minus x all over h. And it would be nice to distribute the negative there, but you could leave it. Yeah. In the interest of time, we'll just leave it. Okay, guys, there it is.